All right, hi everyone. So I know on the if you're watching it from YouTube, this will be the first lecture. We have to do it all over again. So this will be the first lecture of our calculus course, and the only reason I restarted the calculus course again is because I know that semester begins soon, and what better way to start your semester rather than going all the way in the middle, like starting off in the middle section, like in chapter 2 or chapter 3, when the semester just begun. And so I decided that I'm going to do it all over again, but with better understanding, better explanations and stuff. So we will be obviously doing chapter 1.1. First of all, the book that we're going to use is the Calculus Early Transcendentals, ninth edition. You can probably find that in PDF. If you are on the membership page, I'm going to attach that book there. But if you're not, you can obviously download that on YouTube. You can go to Google, type um, Calculus Early Transcendentals, ninth edition, and in respect to calculus 1, 2, 3, whatever, the book already is segregated. So the first few chapters specifically is there for calculus 1, the second half for calculus 2, third half calculus 3. Don't worry about it. Do not worry about, oh, which one is calculus 1, which one is calculus 2. That book has everything. All right. So let us begin with our first chapter: four ways to represent a function. The four ways to represent I used washroom. So first of all, what is a function? When I have f of x is the input. So in this case, x being the input, f of x being the output. X being the input and f of x being the output. Right? So you're gonna have an input. Oh shit. So you're gonna have an input, you're gonna have an output. Not and output, an output. And so you're going to have one on one, meaning one input, one output. Do not jump, do not jump, do not jump. Why I'm saying do not jump is because you're going to, I know some people will say multiple inputs, one output. Do not jump yet. It's a first year maths course. So you can, for example, if you write f of x being 2x plus 1, and if you write y equals 2x plus 1, they're the same thing. F of x typically denotes y, right? So f of x, and you're going to have x being what you call an independent variable. So x is what you call an independent variable, and y is what you call a dependent variable. X being the independent variable, y being the dependent variable. So obviously, if let's say, for example, I did one example. If I have x is equal to 2x plus 1, x being 3, then f of x being 7. Right? Simple. Um, there are general function types. So there are a few function types. So general function types. So you got the linear. So number one, linear, where y is equal to mx plus b. And then you got quadratic. Obviously, you know what quadratic is. Y is equal to ax square bx c. Then you got the cubic, which is so y is equal to ax cube bx square cx d. And then you got the rational. So in ratio, in most cases, you call that fraction. So ratio, you're gonna have f of x is equal to p of x by q of x, and then you got the root equation. So root, where f of x is equal to root x, and then absolute value where f of x is equal to absolute value of x. right? So these are few general functions. Domain and range. Domain means all the values that are allowed inside a box. So if you have a box and these are the items that are allowed inside a box, so that's what you call a domain. Now, um, if you guys are doing computer science as a major, you guys say something called domain. What's inside the domain, meaning what is allowed inside the domain. Guys say domain is. I'm not a CS major, so I don't understand much about CS. I understand more on physics. But in general, domain is what you say, what is inside the domain, right? You guys ask that question, what is inside a domain? Meaning, in simple cases, what is inside a box? Can be toys, it can be fruits, it can be anything. Anything that is allowed. Anything that is allowed. Now, domain is the values that are allowed inside that box. And range are the possible values that exist. Range are the possible values that exist. Domain are the values that are allowed inside the box. If you have minus 10 less than or equal to x less than or equal to 10, that is what you call a range. These are the possible values. These are the possible values. If I have minus 2, 5, these are the values that are allowed inside the box. Now, keep in mind why I wrote that bracket and this bracket. This bracket shows is included. This bracket shows this is not included, meaning you're going to have minus 2, minus 1, 0, 1, 2, 3, 4. You're not going to have 5. 5 is not included. 5 is excluded. So this is what you call a domain, right? Yes, I know there's ambulance and some stuff. It's summer, so motorbikes, 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 motorbikes. And it's summer. It's amazing. It is summer. You know what? It is amazing. It is summer, right? Like, can you imagine like who's here to like if you love a woman, I loved a woman named Valentina Gomez. I loved her dearly, but I know nothing about her. Like I loved her. Like you see the whole thing about that make Valentina Gomez, the whole thing about this shit, the whole thing about me teaching, the whole thing about me, you know, learning quantum mechanics, the whole thing about me learning cybersecurity, the whole thing about me learning quantum mechanics, the whole thing about me teaching was to get Valentina Gomez's attention. But well, what if she isn't here? The whole reason was because of her. Now, can you imagine, like, 2 years from now, 2.5 years from now, I get to see her again, and then she's the same woman who keeps on barking or saying, like, oh, Muslims did this, Muslims did that, Muslims did this, Muslims did that. Could you imagine how scary it would be? Like, 2.5 years later, I'm going to see Valentina does the same thing again and again and again and again. And while I end up someone, can you imagine how scary would that be? Like, holy shit, that's going to be scary. Because she's the very reason why I started this. She's the core, pivotal reason. She's the pivotal reason why I started this. You see, I have that page, Make Valentina Gomez Noriega Proud. I have that. Look at it. I have it. I just hope she ends up someone. If she doesn't, I swear I'm going to be so fucking pissed because she was the very reason why I started this. She's the very fucking reason why I begun this shit. She better be someone. She better be someone. Valentine, I don't know if you're watching this or not, but you better be someone. I begun this shit because of you. I begun this page, this web page, this me teaching, me being on the dean says, me being here, me being there because of you. If you do not end up someone within 2.5 years, I swear I'm gonna be so fucking pissed because everything will feel worthless then. All right, example one, domain. So we know what domain is. Domain is the values that are allowed inside, right? So f of x would be root of x minus 3. Let's say. So you must make sure that x minus 3 is greater than or equal to 0. Why? Because it's a square root. You can't have values, you can't have x minus 3 being less than 0 because that would mean it is complex. Doesn't mean we cannot. Understand this. Doesn't mean we cannot. We can. But for now, we cannot. So we're gonna make sure that x minus 3 is greater than or equal to 0 or x is greater than or equal to 3. So your domain must include 3, but it is not necessary for it to include infinite because it must be greater than or equal to 3. Correct? Why greater than or equal to 3? Let's do another one actually. There is an interesting example. If I have f of x is equal to 1 by x minus 2, then I cannot have x is equal to 2. However, I can have values that is not 2. I can have values that is not 2. I cannot have 2 per se, but I can have values that is not 2. Which means I'm going to have minus infinite 2. 2 is exclusive. 2 is exclusive. That's fine. Union to infinite. Which means I can have minus 3, minus 4, minus 5, minus 6, minus 100. I can have it. But 2, no. The only reason we don't say minus infinite being inclusive, because even if you have minus infinite or infinite as exclusive, it doesn't make any difference. Because at the end of the day, you're going to have a very large value, right? You can, sure, you can write, inclusive, but like that's not going to change anything. Because even if you go for minus 10 million, I mean, that is also a huge number, right? So minus 10 million is included. Even if you do that square bracket, or even if you don't do that square bracket, the minus 10 million is still included. But we do that because, I mean, you can, it's fine. But as long as you know that 2 is not included, all right? As long as you know 2 is not included. So that's domain. Range. Let's do an example for range. We have f of x is equal to x square. And now, obviously, x square will always be greater than or equal to 0. Your minimum output will be 0, which means we will have our range will be from 0 to infinite. Why? Why? Because it's always greater than or equal to 0. My values can have from 0 to infinite. So that's literally my range of values. Because if I have f of x being x square, what are my values that are allowed? Like typically, like what values would typically be allowed? Anything greater than or equal to 0. Here, in these questions, in these questions, it's kind of like a box, a medium-sized box, right? It's kind of like a medium-sized box. And what is allowed that is going to fit the medium-sized box? Because think of this as the small box, and think of this as like little medium box, like maybe little higher than medium box, right? Here, this equation here is the world, is this huge globe who can stay there because there is no restriction there. If I have x square minus 1, that is also not going to change because do I have a restriction here? I don't have a restriction here because at the end of the day, even if I have minus 3, even if I have minus 3, or even if I have x minus 1, that's not going to change anything, right? That is not going to change anything. The common thing for both domain and range is what you do is you have x, you have y, you put the values, you plot the values because x is independent variable, so you can have any x value that is completely fine. You can have any x value, and then you're gonna get y also. You're gonna immediately find out which one is domain, like where, like which ones will have the restrictions and whatever. Because when you do that, you're gonna find out that oh shit, you can't have that value or you can't have that value. So these values will be excluded, right? You're gonna observe that. Cool. What is a vertical line test? Vertical line test is when I have one x value, I have one y value, and let's say x when x is 2, y is, yeah, it is summer. When x is equal to 2, when x is equal to 2, y is equal to 5. I cannot have when x is equal to 2, I'm going to have y is equal to 5 and y is equal to 7 and then y is equal to 9. No. there's only going to be one input, one output. I'm going to have a graph that has one input, that has one output. There's the linear, there's the vertical line test. Again, there is a vertical line test. You can also have for quadratic, because you are going to have for quadratic. But in quadratic, in quadratic, here's one catch. When you have y is equal to x square, you're gonna have a quadratic graph. Let's presume you're gonna have a quadratic graph, correct? Because when you have -3 is 9, 3 is 9. You're gonna have that one line. You can have one line. Like, I mean, yeah, -3 and 3, obviously, right? Obviously, it works. But because every vertical line hits once, just hits once, right? But if I have x squared plus y squared is equal to 4, if I have x squared plus y squared is equal to 4, if I have x is equal to 0, I'm going to have y is equal to 2 and y is equal to -2. So typically, what happens is when you draw this circle, you're going to have y is equal to 2, but you also have to draw y is equal to -2. Why is that? Because both of them outputs what? Both of them outputs 4. -2 also outputs 4. 2 also outputs 4. Now the question is, okay, why didn't we say that -3 outputs 9 and 3 also outputs 9? Then why didn't we say the same question here? Okay, -3 outputs 9, 3 outputs 9. But you see how many times did you draw the vertical line? Once. That's it. You got the points. Enough, khalas. You drew that vertical line once. Here you have to draw it two times. You you cannot be like we are, even if you do that, it doesn't make sense, right? Because those types of questions. So in general, anything that correlates to a circle question, you can't have that. And you can so anything with a circle. So this is a circle, so you can have -2, you're gonna have 2, so it doesn't make sense, right? Even if you have x is equal to y square, even if you have 4, right? So you're gonna have 2 square and you're gonna have -2 square. So again, that doesn't work, right? But you can have y is equal to x square. You can have that. You can. But you cannot have x is equal to y square, because y itself is the dependent variable. Y itself is the dependent variable, because without x, you cannot have y. Now, if x is your independent variable, then which means you can pick any value and the y will change based on the independent variable, right? Now, if I have x as 4, if I have x is equal to y square, and if I have x as 4, then I have to do what? I have to do what? Root x is equal to y. But root x will satisfy what? When y is equal to 2, when y is equal to -2. Right? Cool. Now we have the difference quotient. Very important. This is probably one of the core aspects. So the foundation of derivative, to solve a derivative like the difference quotient, solve f of x plus h minus f of x divided by h. So this is the average rate of change between the 2 points. So if I were to draw a graph, and I'm going to say this point is x plus h, this point is x. So that's x plus h, this is x, right? And then if I draw a line, now think of derivating is like zooming in. So you're going to zoom in specifically on this point, right? You saw this big line, this huge line, and now you want to zoom in. You want to just zoom in. So you derivate it. Okay, I'm going to zoom in on this specific section. I'm going to magnify glass that, right? So derivating is more of like zooming in. So if I have f of x equal to x squared, I'm going to have f of x plus h minus f of x divided by h. Now, obviously, f of x plus h is equal to x plus h whole square. So I can have x squared 2xh h square, right? And then you do that x squared plus 2xh plus h square minus x square divided by h. And then you do the algebra and stuff like that. And so when you do the factorizing, you're going to have h 2x plus h divided by h. So you're going to have 2x plus h, right? I am not going to do these two examples. I'm just going to say it to you. And if you have time, you can do it. So f of x will be 3x plus 1. So this is your task to solve it. Find the difference quotient. And the other one will be f of x is equal to 1 by x. Cool. So these will be your examples if you want to do them. That's completely fine. You can do if you want to. All right. Moving on to piecewise function. Am I going a bit too fast? Am I going a bit too slow? You can take your time. You can pause. You can pause. You can take your time. I'm gonna stop after piecewise function. Then the next one I'm gonna do on the next recording. Cool. Piecewise function. Piecewise function. Don't worry about it. Don't worry about it. So f of x, formula 1 and condition, formula 2. And if you are a member of the page, you are also going to get the exact same notes. You're going to get the notes, right? You are going to get the notes only if you're a member. So let's do an example. F of x is equal to x plus 1, x less than 0, x plus 1, and x squared for x greater than or equal to 0. And now you want to find f of minus 2. Now, where does minus 2 lie? Where does minus 2 lie? Where does it stand? We have two piecewise functions. We have x plus 1 less than if it's x less than 0 and x squared when x is greater than or equal to 0. And we need to find f of minus 2. And because minus 2 is less than 0, we would have to use that equation there. So f of x will be x plus 1. So minus 2 plus 1 being minus 1. Right? Cool. We can do two more examples. We're going to do the absolute value examples, and we are also going to do step function. So if you have absolute value examples, so let's say if I have f of x when x for x greater than or equal to 0 minus x for x less than 0. Now, obviously, if I have absolute value measures the distance, so distance cannot be negative. So if I have, let's say, x is equal to 5, that is going to remain 5. So it's going to be absolute value. Oh, sorry, I forgot to write the equation. So f of x is equal to absolute value of x. So in this case, even if I have x is equal to 5, that will remain 5. And if I have x is equal to minus 5, so I'm going to have absolute value of minus 5, which is the same thing as 5, right? Yes, we are going to stop here. We are going to stop here. Definitely, we're going to stop here. Next, what we're going to do is even and odd functions, increase and decreasing functions, mathematical models, cost models, temperature models. Yeah, there's pretty much quite a lot. It's good that I stopped here. So we're going to do even and odd functions, and then we're going to finish the entirety of section 1.1. Cool. I hope you guys understood. All right. I hope you guys understood.